This is part 2 of section 1.3, finding limits analytically. Just going to go ahead and go over a couple more examples on how to find limits by hand. It's going to be example 3 in this section. This is a limit as x is approaching 4 of this rational expression. Now, if you saw the last example, you should have seen that the basic idea for limits is you want to first plug in whatever number you're approaching. You want to first substitute it in and see what kind of answer you get, or see if you do get an answer. So I'm going to do that. Just plug in 4 straight into this expression. I plug in 4, it's going to be 4 squared minus 16. Denominator, when I plug it in, it's going to be 4 squared minus 4 minus 12. And this is going to get me 16 minus 16, which is 0. On the bottom, it's going to be, let's see, 16 minus 4 minus 12. Well, this negative 4 and this negative 12 also turn out to be 16, but they're both negative, and cancels out with that one, so it's going to be also equal to 0. So this expression turns out to be 0 over 0, which hopefully some of you recognize this from pre-calc. If you don't, that's fine. This is a very significant part that we're at. This is something called the indeterminate form. What that means is that if you arrive at a limit that gets you 0 over 0, it means that the limit does in fact exist. However, you have to somehow simplify the expression to find the limit. In its current state, you're unable to determine what the limit is, but it does in fact have a limit. So I got to go back to my initial problem and somehow simplify it. Well, hopefully you recognize that this is a factorable, and this is also factorable. This is factorable to difference of squares, so this factors as x minus 4 and x plus 4. Down on the bottom, I'm looking for a quadratic, let's see here, that multiplies to negative 12 and adds to negative 1. That's going to be the numbers 4 and 3. Let's see here, x and 4, x and 3. And in order for this to be a negative 1, the 4 has to be negative, which makes the 3 positive. And at this point, it's obvious that I have negative 4, x minus 4, x minus 4 in common in the numerator and denominator. So I can reduce them. So the general strategy is going to be simplify algebraically, and I'm going to reevaluate my limit. So after I simplify, I have to reevaluate my limit. So what I have left over is the limit as x is approaching 4 of x plus 4 and x plus 3. And again, the same strategy applies in the sense that I now am going to just substitute 4 into x and get 4 plus 4 in the numerator, and we get 4 plus 3 in the denominator, and that's going to give me my answer of 8 over 7. So that's what the limit is going to equal, 8 over 7. So the answer to this initial problem, which left in this way gets me 0 over 0, the answer to this, when I simplify it, is 8 over 7, and that's my limit. Alright, next example. Limit as h is approaching a 0 of this quantity. Again, first thing is you substitute 0 in the limit that h is approaching, so it's going to give me the square root of 9 minus 3 over 0, which quickly simplifies to be 0 over 0. Again, indeterminate form means in its current state, I don't know what, I can't find the limit, so I have to simplify it somehow. The way you simplify things like these is from your Algebra 2 and your pre-calc days, is to simplify a radical, you have to multiply by the conjugate. What I'm going to be doing is multiplying by conjugate. the conjugate of this is going to be keeping the radical exactly the same, but just changing the sign that's in the middle. So now it's going to be plus 3. And to keep things equal, whatever you multiply at the top, you have to multiply the bottom by. So it's going to be radical 9 plus h plus 3. And now this turns into, well, when I multiply the two radicals, the square root of 9 plus h and the square root of 9 plus h, when I multiply those two, it's going to be just 9 plus h. The radicals cancel out. Then when I FOIL out this one times this one, well, one's going to be positive, one's going to be negative, so the middle part cancels out. And then the last part is going to be multiplying a negative 3 times a positive 3, which gives me negative 9. On the bottom, I'm going to multiply, I'm just going to keep this as h times the square root of 9 plus h plus 3. And again, I have to simplify as much as I can. So I have this positive 9, this negative 9. That becomes a 0. I could also reduce out this h and this h. So what I have left over is, well, this became 0. This divided out to just be 1. So I have 1 left over in the numerator. In the denominator, I have square root of 9 plus h plus 3. And now I want to reevaluate my limit. Okay. So I'm taking the limit as h is approaching 0, and I end up with 1 on top. Taking this 9 plus 0 is just going to be the square root of 9 plus 3, which the square root of 9 is 3. So basically 3 plus 3 in the denominator gives me 1 over 6. And that's my answer. Now the reason I didn't multiply, I didn't distribute this h into this set of parentheses is because I knew that this h was going to cancel with this h. And this generally happens whenever you're multiplying by a conjugate, is that you're going to have stuff cancel in the numerator and the denominator. So there's no need to multiply this into it. There's no need to distribute. Otherwise, it's not going to be obvious what's going to cancel. So the general rule of thumb is you want to keep whatever this quantity is kind of separate, so you're able to see, what's reducible in the end. All right.